So if in case of a pop, if I want to detect that the stack is empty, then I can just say, well, if SP is 0, it means that nothing was ever pushed on this stack. So the stack must be empty. And I say the stack is empty. It would be a wise thing here to say return and not attempt to crash the computer, maybe, if that's what's required, so that we design a container that is trying to be aware of its own bounds. You know, we can basically just say return. A void function can return by simply using return statement with no return values. That's not a problem. Right here, however, we are required to return something. So we'll just return some garbage value. So say stack is empty and say return -1. I don't know, something, some garbage value. Right? So, but the user will be able to see that the stack is empty. So then, if I do all this, and if I modify my main function to perhaps try to pop from an empty stack one more time. 2 elements are there, they're getting popped. At this point, the stack should be empty. I should be able to see my diagnostic message, right? So build again, and Control F5 to run it. So there you go, right? So the stack is empty. However, the design is such that the main function really never detects anything, that there was something terribly wrong with this pop. So it just normally picks up this -1, which I return from my pop anyhow, and I just print this. So anyway, I guess this is accepted behavior because we're still trying to think about what to do. So that covers this. And I know we're out of time on our regular lecture time, but then let's postpone discussion about those special types of push till next session, so that we have a chance to talk about arrays. So you can ignore number 3. I really want you to basically recreate what I did so far, and let's see what else we can do. Push and pop with arrays. Those are interesting, so I will discuss those. And but make sure you add is full and is empty, basically functions that return Boolean values, whether indicating whether the stack is empty or full, right? So it's basically we already have those checks in place. We already detect very successfully these conditions. Okay, this indicates that our stack is full, and this indicates that our stack is empty. So those conditions should be universal. They will work in any situation under the current design. What else? So we can implement those, and I guess I'll post a function which you can use to test against next time. And we also can use this function print stack, which basically will go ahead and print the stack. However, the stack the pointer element also creeps into this. So how about this? We spent today a very decent amount of time talking about graphical user interface, right? So we got a look and feel and what's involved and what the challenges are and what really it looks like. So next time, I will plan to do the following. It will be probably a very important lecture. So I will go ahead. I will present everything that we need to know about pointers to this point, including everything that we need to finish this homework. And also, I will cover arrays. Pointers and arrays I will cover next time. And then we can use this as the testing ground, like a little sandbox, to make sure that everything that's required here we can implement based on the theory that we create. However, again, if you already started on this project, and if you'd like to sort of like sit down one-on-one, show me what you have, maybe get a direction or anything else, we can stay longer. So here we go. It's 6:15. So let's stop.